Hello everyone, and I'm Dmytro Chaplynskyi from Ukrainian Catholic University and Learning UK initiative. Today I'll present a work on evaluating large parallel corpora for machine translation. And let's start with framing the problem. Why it matters? To build good neural machine translation models, to train them, we need lots of quality data. And if we go and examine the publicly available datasets like parallel corpora from Opus project, we can see that there are 158 million of pairs available online. And this sounds great, but there are a lot of pairs of bad quality, duplicates, errors, and even inappropriate content. And obviously, we cannot manually check 158 million sentences, so we need some automated methods. Luckily, there are a set of models called quality estimation or reference-free quality estimation, which allows you to see the results, see the comparison between original sentence in its translation and get the score. The only problem, we don't know how good are they for exact pair of our interest, English and Ukrainian. To start with research questions, we set at least 3 and like 4th is optional. Can we automatically evaluate large parallel corpora with available resources? How good are modern quality estimation models versus human evaluation? Can ensemble models, like when we put in together different models from different family, can they improve the evaluation quality? And is there things beyond quality estimation models to help? Our approach looks like this. First, we collect all the available parallel sentences pairs from the Opus collection. And for Ukrainian and English, at the beginning of our research, it was 97 million of pairs from 35 sources. Then we deduplicated them using simple hashing function, and we received 55 million of unique pairs, which is still impressive. Then we applied 6 different quality estimation models from 2 families, Comet and Metric X family. Then we did, from our initial corpus, we did stratified sampling by the length and the averaged quality received from the models to get 10,000 of pairs of human evaluation. Then we used humans to evaluate almost 10,000 pairs, and we will touch that a little bit later. Then we created some models to try to fit ensemble of quality estimation models, as well as examining the performance of each individual model. So we created linear, quadratic and beta regression models, and then we published the resources and the results of our evaluations. Let's start with our models. Like this, what took the lots of compute, almost everything we had at the moment. We used 6 models from 2 different families, Comet from Unbabel and Metric X from Google Research. For Comet, we used models from 2 different VMT submissions, 22 and 23, as well as explainable Comet. And when we picked the biggest model we can run on our available GPUs, and just to see if there is a difference between smaller and bigger models, we also included, as you can see, XL and XXL model for the Comet KV. For Metric X, we used Metric X 23 and 24, which was built on top of MT5 XXL, and they have like 13 billion of parameters. All the models were multilingual, and they was announced as ones that support Ukrainian and English languages, and they can work in reference-free mode, so-called reference-free mode models or hybrid models. Then we took the stratified sample from the whole corpora to run them through the humans. We found 2 groups of students, around 20 linguistic students in general. We created a plugin for our crowdsourcing platform called Twulik to run the evaluation and to collect the results from at least 3 different experts on the data we have. So each sentence pair was evaluated with at least 3 scores from different students. We also added flags for inappropriate or garbled content. So for example, if the content looks rude or you can't even get the sense from the original sentence, you can mark it so we can measure the quality aspects of original data sets. Then we collected the results and we processed them. There was a lot of heavy lifting, and I would like to invite you to read the paper for all the details. But what we've got is inter-annotation agreement. ICC was on poor to moderate scale. We did some percentile transformation to try to capture the nuances from different individual contributors, and we've got ICC a little bit higher, 0.542, and there was a higher variability between evaluators, and models in general were more consistent than humans, which is not so surprising because they was trained on pretty much the same data. Then we plot all the correlations with human judgments. So you can see on this heat map, you can see the expert average. This is the averaged results from our expert model averages and different scores from different metrics. In addition to 6 announced models, metric X and Kiwi Comet, Kiwi X Comet, you can also see that we run some experiments using Labezier model, which is used for aligning the parallel corpora, and Biclinear AI score. This is a package, the old package, which was created to remove garbled and inappropriate content before training. Also, eval score. This is a score from our experiment with LLM as a judge, and you can see this probably shows one of the best results so far. Then, on top of these 6 models which I mentioned, we created 3 different ensemble models. Linear, when all 6 models are predictors; quadratic, which is basically average score and squared average score; and beta regression for bounded 0 to 1 data. The best model we've got was quadratic model, which explained roughly 60% of variance, which is not yet great, but we will touch on that a little bit later. We also, as I mentioned, we also ran additional experiments. We used Biclinear AI. It had very poor correlation with the quality estimation models and with human judgments, probably because it was created not to judge the quality translation, but to categorize if the translation is garbled or bad, like inappropriate. We used Labezier similarity from sentence transformers, which shown relatively good correlation, and this is a relatively small model, so this means you can use it if you are bound on resources, or maybe some of your models for quality estimation doesn't support the languages you are interested in. And we used LLM as a judge, as the biggest Gemini model, and correlation was 76%. So simple methods can work. LLM as a judge looks very promising, and in the paper you can find the exact prompt we used to run LLM as a judge experiment. Today we release, first of all, the Vakula framework, which can help you do the data management. It will download corpora for you, it will deduplicate them, and it will run evaluation using models with them. We release 55 shades datasets, which is 55 million pairs with all scores from individual models, as well as 3 models, 3 ensemble models we built. We release human evaluation data if you are interested to evaluate another model or create or train your own. It's almost 10,000 of expert annotated pairs, and we release a Vulik plugin for crowdsourcing evaluation, which you can use, for example, to run your own quality estimation experiment and collect your own dataset, maybe bigger dataset. Don't forget to let us know if you're using one of them. For the future work, first of all, we are planning for another paper, maybe next year, and we would like to introduce professional translators for the evaluation. And we set two experiments so we can compare different estimation methodology. Like we will use one scale versus two scales, and we also can compare the quality of estimation received from linguistic students when compared with professional translations. We would like to train NMT model on filtered data to see if there is any improvement, and we can run ablation study with different thresholds, like removing all the lower scores below first quartile or second or third quartile, and see how it will affect the quality of the neural machine translation model. We would like to extend it to more language pairs at some point, and we definitely looking to run more experiments on LLM as a judge method. So what we learn? QE models, quality estimation, work, but relationship is non-linear, and scores pretty much the way we perceive the scores is not non-linear. Ensemble model, they do improve prediction, but they will require a lot of resources because you will need to run all 6 models to get the data. And around 9% of web crawl data, which can be found in Opus available corpora, they are problematic. They are either garbled or inappropriate. I'm not even saying a word about the quality of translations. It might be just a very random pair of sentences. If you are bound on the resources, you can still use some sentence embeddings to calculate the score. Labezier, which we used, shows that it still provides quite a good correlation on par with some complex models. And as I said, LLM as a judge is definitely good but expensive on such a scale. And now I'm happy to accept your questions, and you can find all the resources that was mentioned during this presentation on this slide. Thank you very much.